Okay, this video is going to cover section 4.6. We'll be doing factoring sums or differences of cubes. And that really is our only objective in today's lesson, is to learn how to use the sum or difference of cubes formulas for factoring. So let's just go ahead and dive right in. So factoring sums or differences of cubes. Remember that we can factor a difference of squares. So let me just give you a reminder. Difference of squares looks like a squared minus b squared. And you can use lowercase or capital. It doesn't matter. Just be consistent in your equation here that we write down. So remember that that factors as a plus b times a minus b. Now we're going to do the difference of cubes and the sum of cubes. Remember also that the sum of two squares is usually a prime. It usually can't be factored. So a squared plus b squared, something like x squared plus 4, which is x squared plus 2 squared, can't be factored. But we do have formulas for factoring the sum of cubes and the difference of cubes. So look at this. There's the sum plus, there's the sum. And we've got cubes, a cubed plus b cubed. On this one, we have a difference, subtraction, a difference of cubes. And the formula for factoring them is almost the same. Notice we've got a plus b, so we've got this binomial times this trinomial, a squared minus ab plus b squared. And then for our second formula for the difference of cubes, we have a minus b times a squared plus ab plus b squared. The formulas are almost identical. The only thing that happens is these two signs switch locations. So the ideas are going to be very similar. So let's go ahead and let's look at how we use these formulas. So we're going to write an equivalent expression by factoring. So we're going to take x cubed minus 8. The first thing we need to do is look at that 8 and recognize that it is, well, let's look at that 8. I can divide it by 2. 8 divided by 2 is 4. 4 divided by 2 is also 2. So 8 is 2 to the third power, because I've got 3 factors of 2. So the 8 is 2 to the third power. You can also grab your calculator and do a cube root of 8 and find out that the cube root of 8 is 2. So we're looking at a perfect cube. 8 is a perfect cube. So now when I plug these into my formula, so I'm going to look at the formula for a cubed minus b cubed. What is it? Maybe I'll write it up here. A cubed minus b cubed. It factors as a minus b times, look back at your formula, a squared plus ab plus b squared. So what we have to look at is what we use for our a and what we use for our b. So for us, a is going to be x and b is going to be 2. And then we just plug numbers, letters, variables into our formula. So we have x minus 2, there's our a minus b, and then x squared, that's our a squared, plus the product of a and b, so plus 2x, and then plus b squared. B is 2, so 2 squared is 4. Right? We need to know what b squared is. It's 4. And we're done. That trinomial is not going to factor any further. So this is our equivalent expression right here. We're done. Okay? Next example. Write an equivalent expression by factoring b to the 6th plus 125y to the 3rd. So what I need to look at is, are those cubes? So I'm going to take the 125, and I can either grab my calculator and do the cube root of 125, find out that it's 5, or I can do division this way. 25, it's divisible by 5. 125 divided by 5 is 5, and then 25 is 5 times 5. So 125 is 5 to the third power. That's all this says right here as well. Okay, so I need to take that b to the 6th plus 125y to the 3rd That's why we're using a sum of cubes this time, because there's a plus sign. And cube, because we've got cubes. So I need to look at this b to the 6th as being, well, let's see. What is it? B squared cubed? Because 2 times 3 is 6. Yeah, b to the 6th is b to the 3rd times, or b to the 2nd times b to the 2nd times b to the 2nd. Okay, plus over here I have a 5 and a y cubed. So what we're going to do is we're going to use our formula, which says we can factor that as, well, let's remember what it is, a plus b times a squared minus ab plus b squared. So what we're going to use is our a is going to be b squared, and our capital B is going to be 5y. So we're going to do b squared plus 5y times, now when we do a squared, we got to do b squared squared, right? B squared squared is going to be b to the 4th power. Because 2 times 2 is 4, so there's a b to the 4th power, minus, we're going to do a times b, and I'll just switch the order a little bit so that my coefficient is in the front. So 5y times b squared, and then plus capital B squared is going to be 5y squared. So we have to square the 5, and we have to square the y. Don't forget to square the 5. You're not just squaring the y, you're squaring all of b. So 5y times 5y, which is 25y squared, and there we are done. It's just a matter of plugging numbers, symbols, plugging things into the formula for the difference of cubes in example 1, or in this case, plugging into the formula for the sum of cubes. All right. Example 3. Write an equivalent expression by factoring. So we're going to do 2m to the 5th plus 2m squared. You know what we should have been doing each time? Looking for a GCF. Right? For example 1, did we have a greatest common factor other than 1? No. Example 2, no. But here, what we need to look at is we do have a GCF. Each of these is divisible by 2, and each of them is divisible by m squared. Remember, you always take out the GCF first. So first thing we're going to do is we're going to factor out the GCF. So we're going to take 2m to the 5th plus 2m squared. It's going to equal 2m squared times, well, let's see, if we divide out a 2 and an m squared, that leaves m to the 3rd. If we divide out a 2 and an m squared, that leaves a 1. Okay, now we're going to take our binomial, this piece right here, and we're going to recognize that it is, my eraser really doesn't want to work very well here, m to the 3rd plus 1 to the 3rd, because 1 to any power is still 1. So I've got a sum of cubes here. I've got an a cubed plus a b cubed. So we can factor that as a plus b. So we're going to replace the a with an m, the b with a 1. So we're going to have a plus b, so m plus 1 times a squared minus ab, so 1 times m, plus b squared. But 1 squared is still 1, and now we are done. That's how we use the formula. Okay, so useful factoring facts. We now have this new formula. We can now factor a sum of cubes. We can factor a difference of cubes. We know how to factor a difference of squares. There is no formula for factoring a sum of two squares. And remember that the first step of factoring is always taking out the GCF. And that is the end of this video.